I'm a cosmologist, so I study dark matter, dark energy, the nature of the universe.
I'm a PhD student, and so I'm hoping that one of the major questions that I attempt to answer over my PhD is to say something about the role of massive stars and UV radiation on star formation.
We study the formation of young stars in galaxies that are nearby. And it's incredibly important because star formation is one of the things that changes galaxies over the time.
Most ordinary stars are forming near massive stars, and the massive stars are dominating how the entire region is evolving.
Stars are what create all the metals in the universe. They have an outsized impact on the structure of galaxies. And the impact, it's not only the stars that are forming, but the way they interact with the gas and dust around them.
So for the work that I'm doing, Webb is much better than what we could get with Hubble, particularly in the near infrared, where it has just much better resolution and greater sensitivity. So it is allowing us to get just more precise measurements without some of the noise that we've had in previous measurements.
When stars are forming, they're very hard to see because they are engulfed in a cloud of material. You need to be very sensitive to be able to see any signature of the star. James Webb gives us that sensitivity for the first time.
Not only does JWST allow us to see through the dust because it's less affected by the dust, but more importantly, especially in the nearby galaxy imaging that we're seeing at the longer infrared wavelengths, it's the dust emission that we see.
I'm particularly intrigued by some of these very massive galaxies that have formed shortly after the Big Bang, trying to understand how they got so massive so early, how they got so evolved so early. It's sort of like, you know, looking back in time and seeing still quite evolved creatures and trying to understand how did they evolve so fast.
I just feel very lucky to be an astronomer studying the Webb data at this time.